when you think about the community and think about the needs of the community, it's not just about, oh, let's build a simple application and show you how to Dockerize it and drop it into the cloud. It's a lot more than that. Like, as you know, Kat, building infrastructure is something that we've done in the past. And it's much more than hopping into an API and say provisioning, or go ahead and provision my EC2 instance or Civo instance. It's a lot more than that. There's a lot of wiring that goes on behind the scenes that we just normally aren't privy to. In a lot of ways, that convenience factor is available to us. So
yeah, I value a little bit more impromptu, just especially in the age of ChatGPT, like making it more human just by being imperfect is honestly an asset in our line of work now. And when you make something like a presentation too perfect, I worry that people feel like you're closed off, and if you derail or get off track or something like that, you're gone. Like, I was performing in a silly little talent show as a kid in my hometown, right? And the person putting on the show was like, "You got to hear this kid," and like moved me closer to the mic and was like adjusting stuff around me, and everyone was like, "Oh my gosh, they're like it's gonna like knock them off of the performance and then mess with their like being in the zone." And I just kept going with it. Of course, I was like one of 4 kids, and I was constantly used to everything going on around me. So it was fine. But one of my takeaways from that experience is when people see you accidentally like veer off course and then you're okay afterwards, it's like, oh, I just saw real life, in front of me, not just some canned performance. And I really want to continue like making style choices in like our own careers based on that same kind of takeaway. It's like, if we can introduce a little bit of chaos and come out like winning, it really is a better opportunity than just a perfect presentation.
I totally agree. Agree. And, on that note, like, we've got an excellent presentation for everyone here in the 90 Days of DevOps community. We're jumping into the intersection of IaC and networking. And it might seem like, oh, we've seen this rodeo before, we've been here before. But the reality is, when we're really thinking about production grade stuff, when we're really thinking about production grade systems and the ability to just codify the entire network stack, it actually takes a lot. It's not just a simple, hey, let me just throw some Python scripts together. It's testing, it's validation, it's making sure that there's interoperability. But there's also this element of, okay, I also need a little bit of a playground to familiarize myself with concepts that relate to IaC. And that's why we're here today. We had the motivation to put together a talk and put together a solution that shows how you can use something like Pulumi and Cilium together to full stack deploy your infrastructure if you wanted to. So we're going to kick off with a demo first, and I'm going to put Kat on stage here. So Kat, why don't you tell us a little bit about what's about to happen, and I'll start asking you questions as we go.
Yeah, sure thing. So I really like the demo first approach, just because if it falls on its face, we can still end on a high note with the presentation afterwards. But we'll go ahead and take a look. So basically what we're going to be covering today is taking an IaC repo. So that's infrastructure as code, where you write very declaratively and specifically all of the infrastructure that you want to build. And then you have that as a reliable and repeatable pathway to a successful deployment outcome. And we're going to be doing that today using a couple of key tools. We're going to use Pulumi to actually code and deploy our IaC. We're deploying on top of Kubernetes. Our Kubernetes is going to be kind Kubernetes, because just about anyone can grab that and tinker with it on their own. And we really want to encourage people to take this demo and use it themselves and then kind of grow from there. And then we're using Cilium as our CNI so that we can deploy some policies on top of that and show how to introduce more secure posture in your Kubernetes cluster.
Yeah, and I like that a lot because we used to think of CNIs as just simple systems that allowed our containers to communicate to each other. But we've seen the evolution of CNIs, especially something like Cilium, climb up the stack. And climbing up the stack, I'm referring to the OSI stack, climb up the stack to address other areas of networking, more specifically the service mesh layers. So what we're going to do is we're going to stand this up. And I think, Kat, I don't know if you've already kicked off your little environment, but I think we could go ahead and kick off this little environment. And I think we've even got a link to share with y'all at the end of this. So each one of y'all should be able to jump in and test this out on your own as well, without any sort of prerequisites other than having access to a GitHub account.
Presumably, if you're watching us, you have internet and browser. So it should be all you need to actually succeed at this yourself.
So one of the beautiful... Oh, go ahead. Sorry.
All right. So just what I did just now is jumping into the Codespaces creation process directly from VS Code installed on my Mac. So with the link, you can go directly to the GitHub page in your browser. There's a button you can click just to create a Codespaces from there, and you can use it in your browser if you want. I'm pretty invested in Codespaces at this point and VS Code, so I'm just using my normal development workflow here. And you can see that it's building the Codespaces right now, so which means it's grabbing a dev container, which has all of our dependencies. And once it's done downloading that, it'll start up our developer environment. So we'll let that run. Marino, I'd honestly be curious. So one of the reasons I was really excited to partner with you on this presentation is because you're really deep in the networking and Kubernetes, like CNI and mesh plumbing and all that stuff. And I'm curious, like, what does Cilium bring to Kubernetes and this network security posture story that we don't just have out of the box if we like deploy kind with defaults and accept Flannel or what have you?
Yeah. So Flannel as a CNI actually doesn't support network policy, if I remember correctly. And that in itself is a huge limitation in the way you can secure your microservices environment. So Cilium, as a networking solution, provides container networking through the concept of networking namespaces. But what it also offers up is the usage of processing in the eBPF space. So policies get applied and are enforced in the kernel space. Why this is important is that when you're considering how the kernel functions, there are a lot of events that go on. And when there's an event, something could occur. Like we could take action on that event. A simple event might be an open socket. And that event is a trigger for us to do something like enforce a policy because that socket was opened or that port was opened. Now, this is exactly how Cilium behaves. Using eBPF, it's able to detect something at the runtime, at the kernel level, when a packet moves. And at the same time, can enforce policy at that kernel level. But a lot of this gets translated at the user level through the Cilium user space side of this application. Anyways, long story short, eBPF is used under the hood to be able to take action on traffic management and being able to apply policy. Now, what's also interesting is that Cilium as a CNI provides network policy capabilities beyond what Kubernetes as a standard practice would offer. Kubernetes offers a network policy resource. Cilium offers network policy, cluster-wide policy, node-wide policy, policies at the namespace level, very granular levels of policy, even to do things like layer 7 policy as well. And why this becomes important is when you're starting to think about that strategy of how you should apply policy for different kinds of services. Some services only need layer 3, layer 4. Other services where HTTP requests are being made and the potential for that denial of service attack to occur, this is where layer 7 can come in. Now, one other thing to consider here is a lot of this functionality that Cilium offers as well is, like, for security, is just one part of it. There's also the networking side. So Cilium allows you to bridge to other cluster environments and treat multiple cluster environments running Cilium as one logical cluster, if you want to think of it that way. And then there's also the service mesh functionality, which we could go on for an hour if we want, but I'll pass it back to you, Kat.
All right. So our code spaces is ready. And we actually get to start practicing some of those cool things that Marina was just talking about. The first step we're going to take here is going to be opening a new terminal. So I just showed the build logs. And now we're going to go ahead and create our Kubernetes cluster. So if you open this in code spaces, the first thing you're going to see is the README preview. You're able to render that here, and we're just going to copy paste from this. So you can reproduce this yourself at home. And it'll take just a minute for Kubernetes to provision here. We'll give that about a minute or two, and then we're going to take a look at some of the state of pods that were spun up. But while that's spinning up, I'm going to go ahead and show a little bit about the key files in this repo that make all of the magic happen, if you're good with that, Marino.
Absolutely.
Sweet. All right. So let's go ahead and take a look at our directory tree. Now on the README, if you're curious like what all of the different files in this repo are, there's a bunch of things that are just like quality of life enhancements and stuff like that. Don't stress over the things that are not in this top group of files. These are the main things that actually drive the outcome that we're showing today. So README, you can copy paste the instructions and reproduce this yourself. This infrastructure as code is all written in TypeScript. With Pulumi, we have the option of Python or Go, or we can even write it all just in YAML if we want to. But we went for TypeScript for today. This Pulumi.yaml is where you set a few basic defaults like the name of the IaC program and stuff like that. And then the make file is where we're actually getting some conveniences like generating the kind cluster. So let's take a look at the index.ts. We have not deployed Pulumi yet. We are about to when the Kubernetes cluster is ready. And I will show you kind of where Cilium comes from in this build. We are deploying a Cilium resource. So this is what a resource looks like in Pulumi infrastructure as code. Now, everything that we create generates outputs. So like if you create a YAML resource and apply that to your Kubernetes cluster, there are return values like some UUIDs, some other metadata, things like that. All of that, including name of the resource and stuff like that, gets output into this constant. It's like a variable in TypeScript. And then we can actually call that and use details from this resource to inform additional resources down the line. But and then the actual library that allows us to deploy the resource is this Kates package. We're importing it right up here, and we're calling it the alias Kates. So Kubernetes Pulumi is the resource itself that we're using. And the Helm v3 release is how we are deploying the Helm chart. Right up here, we have Helm values. So we're telling it what namespace we're going into. We're telling it what the routing mode is. We're saying that the kube proxy replacement is strict because in this case, we're deploying kind without a CNI and without kube proxy, and we're letting Cilium take over all of those functions. So I'm going to close that for now because we kind of had a pretty good introduction, and I bet our Kubernetes cluster is ready. Sure enough. All right, so it looks like we've made progress on that front. Let's take a look just real quick to make sure our kube config is ready to go. And it looks like it is. We're going to use this namespace and take a look at our pods, because I don't think our pods are going to be healthy yet. So Marina, if you want to explain why our pods are not healthy yet, you can jump to that.
Absolutely. So anytime you stand up a Kubernetes cluster, one of the requirements is to make sure that Core DNS is functional because it's the resolution service inside of Kubernetes. But in order for Core DNS to be functional, it needs IP connectivity. And in order to achieve IP connectivity, you need a CNI. So we're at the stage where we actually need to deploy. And no, I'm not thumbs dumbing down. I don't know why it does that, but we actually need to deploy a CNI, and we're ready to deploy the Cilium CNI. So Kat, please go right ahead.
Awesome. Okay, so let's go ahead and move on with our instructions. So we just did the first step, which is make a kind cluster. And now we have just a few things to do to deploy our infrastructure as code. So because we're using Pulumi, we're going to log in and install the TypeScript dependencies real quick. That's pretty easy here. I have a Pulumi access token already in my environment. That's built into the Codespace's environment variables in my GitHub account. So every time I start this Codespaces, it's ready for me to authenticate. I don't have to worry too much about that. And then we're going to create a stack. So I apparently did not update the README, and that's going to suck for all of us. Great. Cool. Okay. So we're going to edit these commands on the fly. No worries. You just see a little bit more CLI action and mistakes, most likely. All right, so this is a stack that we just created, which is just kind of a placeholder for this deployment of the IaC program, because you can use the same IaC program to deploy to dev, test, and prod, or to, west, central, and east. And here we're just calling the stack dev. If we want to, we can go and double check what stack we're actually on. And you can go see like resources that were deployed and history of the deployment over time in the web UI. But with that knocked out of the way, we're ready for the fun part, and that is Palumi up. I'm going to do a skip preview just to reduce the output that we get. And you'll see now that it's starting to create a bunch of resources. So Marino, can you fill us in on what some of these resources are? Because I see a whole bunch of stuff for pods, but also some network policy components and different things in here. What are we deploying?
Yeah, exactly. So I don't know how many of you are familiar with Star Wars, but there are a few different kinds of ships in the world of Star Wars. Now, anyways, what we're deploying are a few applications that simulate whether or not a spaceship is allowed to land on the Death Star. And so we have a network policy that we've deployed called Rule 1, and it's a Cilium network policy, which is a Cilium custom resource. And what it's saying is that only the TIE fighter can land on the Death Star, but the X-Wing cannot. Now, for those that are familiar with Star Wars, you'll know exactly why that's the case. But the reality is we have a policy in place to enforce that particular operation. So this is exactly what Cilium is deploying for us. It's deploying the 3 different applications, which are the Death Star, the X-Wing, and the TIE Fighter, which are just pods that are going to make curl requests. And then we have a policy, a Cilium network policy, that just ensures that the X-Wing cannot make a curl request to the Death Star or land.
Cool. All right. So it looks like our deployment completed. Now we talked about the Pulumi resource for the Helm chart. And one of the things that I did, usually you won't output all of the resources that a Helm chart produces, but for the sake of demonstration, I wanted to go ahead and include that. So you can actually see all of the child resources from that Helm resource that get deployed. And you can consume those. So if you actually want to like pull out an IP address from the resource or something like that, that's what the IaC enables you to do. So now, with all of that deployed, I believe we need to do the steps that I put a placeholder on the README for before the demo, which means we're going to jump down to crazy details. We're going to copy paste some commands and edit them to correct. And I will update the README with the actual commands when we're done recording. All backwards. It's all backwards.
So exactly. And just so that everyone is aware, the pods that we just deployed are actually going to be in the default namespace. So any sort of calls, like curl calls that we make, need to be made to the default namespace as well. This is why Kat is making that modification here in the fully qualified domain name right now. And once we make that request, we'll see what happens.
Yeah, you totally gave me a perfect demo, and then I just like chopped it up, and I was like, no, we're going in the default namespace, and that changed everything. All right, so we just did an exec command in the TIE Fighter pod. So let me actually take a look at our default namespace pods. The TIE Fighter pod is this one right here. Tell me what we just did.
So we actually just made a call, a request to the Death Star from the TIE Fighter, simulating a landing. And if we actually just ran that same get pods command again, but also appended the dash dash show dash labels, we're going to notice something as well. And if you notice, the X-Wing has a different label than the TIE Fighter and the Death Star. So its org equals Alliance. Meanwhile, TIE Fighter and Death Star have an org equals Empire. Now, Kat,
Oh,
what
cool.
happens if we try to curl from the X-Wing to the Death Star?
Yeah, let me grab that other command that I need to chop up. All right. Again, we're going to edit this one to default namespace. All right. And in theory, this will not work like it's supposed to. Let me actually go ahead and restart that command with a verbose flag on the curl command, just so we can see that it actually is trying to do something. All right, so it is trying to resolve to the Death Star pod and get a response from port 80.
So this is perfect. Now, if we want to maybe flip over to K9s,
yeah,
we could probably take a look at that policy.
We're going to do, the policy is going to be applied to the default namespace, right?
Correct. And it's the Cilium network policy resource we're looking for.
And I am not super practiced at navigating CRs in
So
K9.
I would just search for Cilium network policy. Exactly.
Oh, sweet. See, K9s is awesome.
And then, yeah, exactly. So now we're looking at this YAML, which tells us exactly where the request is going to originate from and where it's going to. Now, if you see here, all this policy is saying is only allow traffic from endpoints with labels matching org equals empire. I don't think there's anything else in this policy, right?
Nope.
Okay, yeah, that's it. This is basically a default policy that standardizes on locking only things with the label org equals empire. Org equals alliance will automatically be blocked because of that policy. And it's because of an implicit deny all that exists in that Cilium network policy resource. So we validated that we basically got IaC up and running. I mean, there's so much more we can do. We can really expand, and we could like turn on BGP and stuff like that. But we'll stop there and let's flip to the slides and take a look at some concepts. So let me go ahead and add my slides to the stage. And I know we didn't do some introductions, so I'll briefly allow us to do some introductions. Kat, why don't you go ahead?
Sure, thanks. So my name is Kat Morgan, and we have successfully performed the demo, which means I can tell you who I am. So we have, I'm here representing Pulumi. I'm all about Palumi and have been for years now. Recently joined late last year. And I'm part of the community engineering team. So get to do fun stuff like this to create resources to self-educate and accelerate your cloud automation journey. Marino,
awesome. And
who are you?
Thank you. Who am I? Yes, my name is Marino Wijay. I am an open source advocate that specializes in networking, and I work with the Empathy Ops organization to deliver so much content around cloud native via Twitter Spaces and live streams. So check us out. Now, having said that, why don't you tell us a little bit about the different ways to ops?
Okay.
Go
I
ahead.
was super excited about this. I am always excited about showing off this slide. There's not a lot here, but it conveys such an important message. So ultimately, and P.S., I hate writing slides, so that I'm excited about this is just weird. Basically, when we take a step back from the ops development and operations story just in general, the timeline is really interesting because initially we all had to be wizards and understand procedurally, step by step, how are we going to achieve the outcome that we want. You know, if we want to create a new service and all of our production servers are already at 100% or too close to that to put yet another app on the production cluster, you know, you're going to sit down, go to the drawing board and think, what companies do I need to requisition? What hardware from? And after I get that hardware, what steps do I need to take to provision it and prepare it for running workloads? And then after that, I need to figure out what the workload actually requires to run on that platform and make all of the changes to deploy it. And that might be running CLI commands, writing bash scripts, or all kinds of imperative things where you're performing step by step in series. And that can be a successful path to an outcome. But as you're going down that road, there are constantly opportunities for taking the wrong turn, like writing in the wrong IP address or copy pasting the wrong variable in, or just missing a variable entirely, which sends your automation off into who knows what tangent. And then you have to figure out what went wrong and how to recover. So that is kind of this imperative, almost ClickOps style of operations. We transitioned from performing all these steps to automating them, which took us closer to a programmable orchestration story. But automation still has its flaws. So if you have a missing variable or the wrong variable in place and your automation is doing what it's told, it's going to do the wrong thing, which means it could either just not be successfully deploying what it needs to, or perhaps it could actively be causing damage somewhere, right? And that's something that we get really nervous about with automation, especially during like change requests, when you're rolling something out that is a new capability or feature or architecture of your infrastructure. And when, as the industry matured and we grew into things like Kubernetes, where you have this API pattern where you tell a system what you want and then it goes and makes it happen, we started realizing that declarative operations is the most reliable form of declaring what you want and getting it. And that is kind of the story that we're showing off today from the infrastructure as code side. It's something that I'm super excited about all the time, because once I've achieved something successfully, I don't want to have to do that again, right? That's a lot of mental load and tedium that I just don't want to have to know is going to happen in the future. And with IaC, once you've succeeded with something, you can reproduce that success or iterate and build off of that in other projects. Really, really easy, just by forking your code or making enhancements and change requests in your code.
I love that. It's fantastic, because that just segues right into what I have to say around what I view when it comes to networking and infrastructure and how we can configure this all in a very simplistic fashion. So there's so many different personas that exist in the cloud native space, and I'm just like showing a subset. We've got the developer, we've got the platform engineer, the cloud engineer, the SRE, and probably a lot of roles in between. But there's something that we see with the platform engineer that it's very relatable to the network engineer, because they're both working on very similar platforms. Now, what's very interesting is everything that we see in the green boxes, Istio, Cilium, Envoy, Kubernetes, OTel, policy engines, whatever we can think of, is easily configured as code. Now, for network engineers, that means maybe learn a stack, learn something like Python or TypeScript, which has me thinking maybe I should go learn some more Python and learn some more TypeScript, because then you enable yourself to work with technologies like Pulumi to be able to automate the provisioning of your network infrastructure, which now ties heavily into the network automation streams. And Kat, I believe one of the co-authors of network automation works at Pulumi, if I'm not mistaken.
Yes. Okay. So Scott Lowe is on my team, and he is really good at Palumi and really good at networking. I think you and I are going to be interviewing him in the near future. So that's going to be a lot of fun to really deep dive into the mind of a practitioner that is already fluent in automation, but understands networks with the depth required to literally write the book on the topic, right? So I'm super excited to have him as a resource when it comes to looking at these network automation puzzles.
I love that. So there's so much configurability, and Pulumi, as an example, a very strong example, enables a lot of that. And then you think about the OSI model, which has never changed. Sure, we don't play with the session or presentation layers, but all the other layers are still offer up an interface that we can interact with, that we can configure, interoperate with, right? And to me, and probably to you, Kat, the more specific technologies we'd probably focus on are Kubernetes, Cilium, and Istio, or technologies in that general space. But let me peel away some of the layers of the onion for a second and talk about the container for a second and how it gets on the network. There's a lot of bridging that goes on inside of Linux to make this possible. We're actually creating a network namespace that has virtual wires attached to a virtual switch that is then attached to an exit interface on your host to get to the outside world. But imagine if we had to sit there and do this all the time. We cannot do that anymore. So this is why CNIs exist. They take care of this process because they take care of the onboarding of a container and giving it access to the network, and also take care of the offboarding of a container when it needs to remove access to the network. That's automation. Now, when we think about this at scale, oh, sorry, go ahead.
No, so two things. I was really, really just amused at the concept of ogres and networking having a lot in common, because they both have layers like an onion.
Yes.
But then I'm really interested. So when deploying VMs and stuff before containers happened, we had a lot of work to do to track IP addresses and things like that. And manage IP addresses as a very valuable and limited resource, right? So the CNI kind of takes that chore out of our hands and just automates it all into the background, right?
Exactly. That's the whole process of IPAM. And IPAM needs to be abstracted away from us because it's an operation that was, like you said, we would statically assign addresses to resources, and then DHCP took over for us. But then if we needed something to really scale, the concepts of IPAM, integrated into something like a CNI is exactly where we need to be, because that functionality gets extended out into the physical world if we really wanted it to. And then we think about like bare metal. We think about, the networks that exist. Heck, if we really wanted to, and I think Kat's probably working on this right now, is how to bare metal provision hardware and maybe get Pulumi to do a lot of this for us, right? And then we get even more advanced. We're thinking about massive scales of networks that we own, we control, that we want to kind of make it look like the cloud providers at times, but not entirely. And so automation is making this possible. So then let's say we zoomed in for a second and we said we wanted to implement some BGP. Well, I wouldn't sit here and log into a router or the Cilium control plane and write this configuration. I'd pass this in desired state. But this would live in version control. And then this could also be written in the form of TypeScript or Pulumi, and in actuality be passed in when Pulumi up is run. So there's less and less of us having to interact directly with control plane components in networking. But ultimately think about the different pieces that we actually need to make IaC possible. We need hardware, we need SDN, we need some layer of operating system, and we need to pick and choose between bare metal or something containerized or something in between, whether it be micro VMs or full-blown VMs. Now, having said all of this, IaC is going to make this possible. Kat, why don't you actually tell us about infrastructure as code? Because I think we've danced around the idea a little bit.
Yeah, so not everybody is caught up on what infrastructure as code is yet, and that is perfectly normal, because in the breadth of technology that we face, there are a lot of moving pieces, and to be good at anything, you have to put a bunch of the other like interesting tools down and focus on your core skill set. But it's exactly that broad technology field. Like if you just look at the CNCF landscape, right, there are hundreds and hundreds of projects, and trying to be able to build a production consuming many of those components along with, for example, the AWS catalog is just what, thousands of cloud services now, and having expertise that is mature enough to succeed across that many different technologies is really, really, really difficult, and either requires massive teams or extremely efficient operations. And that's really why infrastructure as code matters. We can talk about how it's, easier to achieve repeatable outcomes successfully over and over with fewer human error opportunities, just because you're controlling so much in code. But really the power comes into play when you realize, especially that big network diagram that you showed requires thousands of resource objects that you have to control across hundreds of technologies to all come together into your app getting to your customer, right? And so infrastructure as code is that key piece that allows you to write the outcome that you're wanting. It's almost like going to a drive-through instead of like going to your kitchen to get a hamburger, right? If you go to the kitchen, you're going to get the buns out of the cupboard or make bread if you're really, really, culinary. And then you're going to grill the burger and you're going to slice some tomato, all these things that you have to do to get the burger. And if you go through a drive-through, you're saying, hey, I want a burger. You're not telling them all of the steps to create the burger, right? You might say, don't put pickles on it. I like pickles. I don't know why people don't like pickles. Tomatoes are great too, right? But basically, Pulumi is the drive-through option in the cloud orchestration game, where once you have written your IaC, you say what you want, and then you just get it. And I really like anything with that pitch. Like, really, tell me a coffee maker where I just say, hey, make me a coffee, and it just gives me a coffee. I'm going to buy that, like, when it happens. Just letting y'all know.
And I think it's important to emphasize, like, it's less about the actual maker and it's more about the flavor, the bean that you use, and it's your desired bean. And I think, like, when you think about all those different languages, that's your desired bean. Hey, I want to write it with Node. No, I want to write it with Python. Well, it's up to you, right?
Yep. Choose your roast.
That's exactly.
I'm going to use that.
that.
I'm taking that one. I like that, Marino.
Choose your roast. Awesome. Okay. Now, let's talk about that policy of code for a second and what that means, because I think we also, when we think of policy, when I think of policy, I'm thinking a set of rules we need to follow. And if we're going to do the same in code, if we're going to do the same for our applications, we can write this as code. We can enforce this pretty easily. But how does this actually look? What would this actually look like, Kat?
Yeah, so some of the risk in building a self-serve platform for app teams, which is, a big conversation popping up with the talk of platform engineering, really getting more volume this year already. What if an app team deploys an app that is not compliant with your security posture for your production, right? Who is responsible for knowing and enforcing? Because you can put all of the, edicts and policies and business hygiene acumen into a document and then just expect that all of your app teams to be compliant, right? And there's a little bit of a self-governance type of responsibility that is inherited by the app teams when that happens. But the risk, if there's a mistake, is really, really big. And again, we're talking about very complex systems. So if you miss a couple of lines of config that makes your app not compliant, there can be a big fallout from that. In our case, with this demo, because the policies that allow or deny traffic between pods are based on the network policy enforced with tags on the application, if you deploy your app without tags, well, in a correctly configured cluster, your app just won't work, and you'll be pretty aware of that, right? But if you're deploying and you're missing those tags and you have, say, read-write network access on a resource in your network, missing those tags to enforce the policy is a pretty big liability. And one of the cool things with Pulumi is you can apply a policy to your account level to say, hey, look, make sure that tag application tagging hygiene labels on applications in Kubernetes follow this format, and reject anything that doesn't. And it's going to say, if we wrote our IaC that we just deployed without the proper tags, it would just reject that deployment and say, no, you can't do that, please remediate, and then we'll try again, right? And that's one of the powerful pieces of IaC. So you get to enforce it in a couple of lines just by writing a little block of the policy in. And then you get accountability for your own, like you can sleep at night because you knew you checked all the boxes, right? Because there's a mechanism in there to continually enforce this compliance. So if you're app deployed, it's enforced within the network policy practices of your organization.
And what about the reusability aspect of this? What does that mean for us? Like, I feel like with automation, there's a lot of things that get to be reused and almost templated as golden processes almost.
Yeah. So when you write some IaC, and then you move to writing another project, sometimes it can feel like you're rehashing all of the same things that you did before. Sometimes just copy pasting or forking the repo, if you have it in Git, which you should, can feel a little bit redundant, even if it's kind of a step. Wow, I am totally losing my train of thought here. So I'm glad we get a post-production on this one. All right, so can you ask the question again? I'm going to try again.
Yeah, that's fine. And no, this is not going for post-production edit. This is literally just being fed right to Michael. So
oh my gosh. Okay, well, it's a trap.
You know what? No, you know what? No, it's good because like I think it's worthwhile that the community gets to see that this stuff happens, right? Like we're not perfect people here. We'll make these same mistakes when we're up on stage very soon in a few weeks. But the idea is like consider limiting toil, right? Limiting that repetition and the usage or the reusage of some of this code templating that you might have started off with one project.
Yeah. So, okay, because we're using general purpose programming languages, it is really easy to generate a repository of commonly used resources. So if you define a method or something like that in your code, you can import that as a library into your code, just like we imported the Kubernetes, Pulumi Kubernetes package as that Kate's alias in the IaC. And then you can just call in various components that you're already intentional on using in your new project. So if you want to pull in that policy and make sure that your tags are compliant, you can have a central repo where that stuff is all written, and then you can just call it in all of your different consuming repos. And then if there's an update to the policy because, hey, we found a way to make our production more secure, you update that in your component, you update the versions that you pulled that library in from in your consuming repos, and suddenly you're compliant again. So instead of telling 10 different teams, hey, we changed the policy, now you have to be compliant this way, a lot of times you can just update that central, core library we call a component resource, component provider. And then all of your other teams just get the note, hey, there's a new release of this policy, bump your releases. So that can be a even maintained and automated with things like Dependabot, right? Where GitOps comes into play and starts making just the daily life of IaC operations much less laborious.
I love that. And that's a great segue into the fact that, you know, automation and some of this GitOps approach actually really helps the decision making around like how we would go about provisioning cloud native infrastructure, but also supporting the same applications on top of that. And at the same time, when those applications need to scale, it needs to simultaneously tell that infrastructure to scale in lockstep without, you know, overinflating, but also downscaling when required. And all of that is automation. All of that is possible because of tools like Pulumi and other systems out there. So,
and CNIs.
Anyway, yeah, it's fantastic. So just to wrap up, we actually started off with a demo where we showed you how Palumi helps bootstrap an environment where networking for your containers is ready to go, policy is ready to go, and policy is already enforced. And we can make those changes to policy when we need to, and it could get re-kicked off and reapplied into our infrastructure as needed. But then we also got to see some more of why this is important, why IaC is important, why it helps us in our daily ops and optimizes how we operate our applications. Kat, any final thoughts?
You know, I would honestly just recommend that people go to the README on the project, click the open in GitHub code spaces, and try the steps yourself. Whether you choose other infrastructure as code tools or other CNIs, there are multiple ways to achieve this same story. These are the components we're familiar with. They're what we chose. But give yourself the confidence of trying it and seeing all those things come together into a successful outcome. Maybe tinker with it a little bit, like add a new app to another namespace, right? And then see how you can play with the policy and control whether or not there's cross namespace networking allowed, things like that, right? Just dive in and play with it. You don't have to be an expert to make progress. Obviously, you can tell that is true because we are editing the slides live. Apparently,
yeah,
post-production, so now we're even.
Yeah, I know. I was like, hold on a second. That's not my handle. But anyway, I love this.
It's been a blast. Like putting this together with you has been really fun. I've learned a lot more about Cilium. I didn't even know how to deploy it before. So it's been a blast. I'm sure others will have fun when they dig in as well.
Yeah, and it's been a blast for me too, because we're still continuing this journey. We still have to present this one more time elsewhere at Civo Navigate. But at the same time, you know, I've learned that TypeScript provides some familiarity to me because I've programmed in Java and Go before. And so like I can understand what that TypeScript file is telling me and where I can input things around Cilium. So there is a lot of transferable skill set. So folks that are developers, easy enough for you to get onboarded and start using some of this stuff. Folks that are operators like me, come from the infrastructure side, it's easy enough to get onboarded and start using some of this great technology that Palumi has to offer. Anyways, please follow us on X or Twitter and check us out on LinkedIn. And we hope to see you around in the community. Take care, everyone.